Hello friends, welcome to Intuites.
Understanding normalization, there are 2 points. 1. Why is it needed? 2. What problems does normalization solve? Understanding normalization is a technique of organizing the data into multiple related tables to minimize data redundancy. What is data redundancy, and why should we reduce it? Let's begin the class.
And hope my screen is visible completely, correct? Okay, so let's get started. And in the last class, like what we were discussing about the normalization, introduction to the data engineering. So this course is about all the data engineering concepts and even what the tools, all the things we'll use on the Azure world. So basically we'll start with the first tool specific, that is called your database. Right? And in the database, we are talking about the SQL Server database. You can use any other database, as I told you that in your system you have something else. Like instead of if you have a MySQL or something else, I want to work with that, I'm open to that. There is no issue with that. Okay? So and there is there will be syntactical change will be there when I'm writing something on the SQL Server, and where there could be change, there will see. And if you're not able to follow that one, that will see that what the syntax change will be there, and you need to write according to your database. And apart from that, if somebody has installed the SQL Server, so the first of all thing is, before entering to the concept of the database, first of all, how to install it is. Again, I'm repeating this. So you need to just go to your Google, okay, and just put SQL Server download, okay, and there will be a first page will be open up for you here, okay, the Microsoft site. Click on this and don't try to run anything. Instead of that, go for this developer edition. Download now. SQL Server 2022 Developer Edition. Okay, and just download it, and simple installation will be done. Okay, any questions? Anybody have in this, or everybody install this all, or anybody have other database? I just want to confirm that.
Hey, SQL Server, this one is applicable only for the Windows machine, right? There is not for Mac, right? Or you have
Correct.
Mac also?
We don't have Mac. We don't have Mac.
Oh,
That's correct. Because the Azure also, it is more of a Windows SSMS, which is nothing but your SQL Server Management Studio. So that SQL Server Management Studio is something like Microsoft SQL Server Management Studio. This is an IDE, okay, where you can write your database code. This is the IDE, and underneath there is a SQL Server. Makes sense? Anybody have already installed it, or any issue you are facing? The normalization. Let's go to the normalization slide here. So here, can anybody explain me like what is normalization exactly? If anybody knows that.
Normalization is effectively designing database without data redundancy.
Your data redundancy, we are talking about what? Your data redundancy refers to what here?
Duplication.
So basically, if I talk about the normalization process in a layman, the way you are designing your data, how you want to, and whether that data, any meaning is there, whether that data having some duplication, okay, and whether that data where you are storing up can correlate to other data. All this principle, whenever you are designing a system or designing a database, we should always consider. Okay, so that is the process is called, or is all about called the normalization. Here I want to highlight one thing here is that when you are talking about the normalization, right? So there are basically, let me put it in this. So there are actually in a real time there will be two kinds. One is your OLTP system and one is called your OLAP system. Online, what is OLTP? Online online and transaction, and this is online analytics. Okay, analytics, online transaction processing here, and online analytics process. Let me give you a brief on this, what exactly this two system is all about. Because everybody is using their bank accounts, right? So either you are using your mobile banking, all these things you are doing it. Now, suppose you log into your bank account and you want last 3 months of your bank. Will you be able to get it through your login immediately? Download, you can do it.
Yes,
1 year,
yes,
5 years?
not possible. Yeah.
Not possible 5 years. Why it is not possible 5 years, guys? I know there is a rule on the bank. I understand there is a protocol on the bank, but if I ask you technical here, like why it is not possible?
Many records will be coming in long back data.
Sorry?
It's been a long time and many records, many
Okay.
rows. Yeah.
Okay. So the first thing is when you are trying to log in, it is not keeping history beyond 1 year, correct? Or you don't have access to the history of your details beyond 1 year. That's why you are not able to access. Makes sense? That's what is happening. But somewhere down the line, they are storing the data of your all transactions. It could be more than 1 year, 2 years, 3 years data is. Okay, this is the first point I want to highlight. I'll come to that. What is this? Second, you're not keeping the history. Second point is, suppose you done a transaction, right? Today you transfer some amount or you do some swipe, whatever maybe. Is it affecting your bank statement or whatever your balance statement is there? It is getting reflected immediately or it is taking time 1 day or 2 days? Yes, question is up to you. Be interactive, please. Hello?
Can you
Am I
repeat the
audible?
question, sir? Can you repeat the question once?
My question is, you did some transaction on your account, okay?
Hmm.
That reflection is happening immediate or it is taking time?
Immediate.
Immediate.
So the next point is, so just think these 2 points. First of all, it is not keeping history for 1 year when you are talking about the bank transaction, and there's a immediate. So the system, okay, the system which react immediately, process immediately, and whatever you have done it, immediately it will show you. That system is called your online transaction process. Okay, in the sense transaction happened, automatically the reflection will. Okay, and the other process, OLA process, is something like we are keeping the data for history. Okay, we are keeping the data for the history. So here, because since the transaction wise, whenever you have done some transaction, immediately it want to show everything, is called your online transaction processing. Okay, in the sense transaction happened, automatically the reflection will be there. And the other process, the OLA process, is something like we are keeping the data for history. Okay, we are keeping the data for the history. So here, because since the transaction wise, whenever you have done some transaction, immediately it want to show everything. So we will keep very less amount of data on this system, or max 1 year, or maximum to maximum 1.5 year or 2 years. Other than that, if you want, then I need to go to the OLAP system. That's why when you are having a system and you want the statement beyond 1 year, then you need to revisit your branch. You can request there that due to so and so reason, I need my bank statement for the last 3 years or 5 years. Then they will have, the bank people have access to other database where the data is getting captured of your history. From there, they need to get it. So that system is called the online analytical processing. Okay. The same system lies. Any questions up to here?
Samir, can you please repeat online analytic processing again, please?
Online process. Online, suppose very simple guys. As I told you, have a credit card, you have a suppose bank statement, right? You
Mm-hmm.
go to the ATM, put your card, put your PIN, and withdraw some money. That, suppose, let's say today, just for a sake I'm saying that, suppose I have 10,000, right? So I
Mm-hmm.
deducted 2,000. So that 8,000 remaining on my account is getting reflected immediately, or it is taking two same time, right? Immediate, right?
Mm-hmm.
Immediate. So you done a transaction, the reflection is that was all your online transaction. If the system is that online transaction system, then this could be happening. Okay?
Mm-hmm.
And whereas analytics, you are doing your transaction. So end of the day, suppose this system is always keeping 1 year up, just like
Okay.
in your bank statement. Beyond 1 year, it is not possible for a, at least just like our bank customer, we will not able to download anything because we will not have access to that. For that, we need to revisit your bank. They have the access to your account, which is beyond one. That we are there. Okay.
Oh,
So
okay.
there, that is called your online analytics. So
Okay,
in
thank you.
this,
Mm-hmm.
now
Mm-hmm.
this applies to the real timers. The same kind of, there will be so many system will be there, which will be online transaction, and there will be some data will be there online analytics. So let me give an example. Have you heard about a Salesforce? Anytime have you heard about Salesforce or any kind of ERP? Anybody heard about this? This is
Mm-hmm.
not, we are not discussing, we are not learning Salesforce, but
Yes, sir. I heard about CRM
so
system.
CRM, correct, ERP system or CRM, whatever. So here, when you are entering to the Salesforce, right? So there, this works on the transaction date. So daily you are transaction, daily you are immediately within a fraction of a second you will get in. This works on the OLTP transaction. In the sense, we have a data and we are just showing it. That's it. But whereas all the data world, data analyst, or even your data engineering, all these things, right? They works on always on the OLAP system. OLAP system means the database will be on the OLAP. What is OLAP exactly? So our job, as you know, the data engineering or the data analyst, its job is to get capture data from different system, right? Suppose I'm capturing one data from Salesforce, capturing some data from the HR, I'm capturing some data from the finance. So there are mix of burden of data, and our job is to pull the data and make it as a one system. That is called my centralized warehouse, where I want to keep it all the here. The basic rule is that okay, that is fine, that they in that system, on the source system, the transaction is happening daily or in a 1 hour basis, but is our job to store the data on an hourly basis, so that you can understand completely. I'm bad on that. Let's try. So let's take, I have a system here, one system here, then I have a system here, and I have a system here. Okay, so let's take an example here. Suppose this is my, write this somewhere. So this is, let's take your Salesforce. Okay, this is your Salesforce. Let's take, this is your, oh, bad, very bad. Sorry for that, but you need to understand. Let's take, this is your HR data, and this is, let's take the finance data. Okay, so here one database is there which is holding transaction wise, just like your bank statement. Okay, each and every time if somebody logins to this one, he will get the current data, whatever is happening currently. Same thing for the HR and same for the finance. Make sense? Now, any questions up to here? Any questions? Just do let me know. Now, our job is for the data engineering worlds, right? So we want to make a centralized warehouse. Okay, where you want to keep my history. Okay, I want to keep my history here as well. I want to keep my history along with one dedicated database or warehouse, I can say here, warehouse DWH, where I want to keep it, all this information. Now here, my job is to not to store the each and every transaction. Okay, so what exactly it happened, how it works is that this is a transaction system. Okay, and it is running daily. So at the end of the day, once all the transaction happen on each and every
Excuse me, sir. I'm sorry, I lost the connection. What is it? S and HR and
oh, these are simple system only. Salesforce, one HR, one finance, one
okay.
areas other where we are capturing different data.
Okay. Yeah.
Okay.
Thank you. Thanks.
So now on this one, so that's as I told you that this data is just like the transaction. Each and every time it will be holding that. Right? So at the end of the day, or suppose you decided that after, let's take somewhere around in the night, suppose 10 p.m. PST or 11 a.m. PST or EST, whatever the time zone which you are working on, we decided that till that time, whatever the transaction happened, I want to do a back. So there should be a mechanism here now at 11 a.m. PST from all this system, right? Let's take on a 11 a.m. PST. We decided that. Let's take 11 p.m. EST. You want to load this data. Whatever the data I have, I want to store it here. Okay, I want to store it here. Each and every day, this is the task. So what in that case, what happen is, here we are holding the data. Let's take today is 15th or 14th of May. So here we are loading all the data, and at 11 p.m. EST, all the 40th transaction or the 40th May the transaction will be gone into. And next day when you comes up here, you will get all the 15th. I'm talking about daily. There could be chance that we will be storing the 1 year also, but I'm talking about the daily one. Daily transaction is happening, and on the end of the day, it is going to the your this one, the data warehouse, and the next day when you log into this system, at least you will get the next. This is the way, and this is called your transaction data, and this is called your analytics. And from here, you can enter to your analytics, which is will be connected to your. So the data analytics always works on historical data and huge amount of data. That's why it is called the big data, right? Because end of the day, we need to analyze so much data of this. You think like that. Suppose any customer is coming and he wants to compare last 10 years of data or last 5 years of data of his different ERP. So
So
it is
you mean
impossible. Word.
so you mean to say that there will be two databases, one for data warehousing and one for data analytics?
Data analytics. Where is data analytics?
I mean, there is
Data analytics is not a storage. Data analytics is a job responsibility.
no. I'm saying there is one data warehousing where you fetch all the data from the systems and keep it there.
Hmm.
Data warehousing.
Correct.
So
Correct.
data
Yeah.
after that, where it will go? You're saying it will go to one place.
Nothing will go. It will be there, and that from there your
Oh, from
job, the data analysis.
we
Yeah.
work on top of that data warehouse.
Correct. Correct.
Okay.
So in this case, we can compare your history data and everything. Now tell me a couple of questions. Okay. Which system will be fast? Your transaction database or your analytics? Which will perform better? In the sense, in the form of a processing.
Transactional,
Why?
because it has to update each last second data also.
Yeah, every day.
Every day it is faster. But how faster in the sense you are getting the data immediately? That's what you are talking about, or but it is processing very less amount of data, right? Processing wise as well. Very huge, very less amount of data is there for that. So it is processing faster. That's understandable. That's the way it is working. But most important data is this: is that capture every and you are here. If I talked about all right, so the configuration wise, like this database required highest configuration. I'm talking about your view, RAM, where it resides, database, right? It needs more, holds more amount. And this system rarely we used for your data analytics job. You are going to work on any kind of analysis on the data. This is not a good system to analyze because this is more of a very transaction, very real data, right? But we need always the data for the right? So that's why always the data analyst and end of the day today if you are running your report, you are that's the way one day before or one day after. That's the way your any questions over here. I'll explain you one more.
So, don't we do the same day data, like reporting on the same
If
day?
very rare will get that area system. So because business work like that. If it is there, yes, once in a while they need it. So that time too, either we can connect this, but here there is a problem that I will come up connect this direct, or we can do one. This suppose they still need a completely live, then this process is running right. You are running once in at 11 a.m. That you can do something like suppose they need immediate, then you can put like every 2 hours.
Okay.
Okay. Every 2 hours, the refresh will be happened from that, and they feel that yes, that's a complete transaction. Some kind of this is it's added pressure. Added pressure in the sense each and every 2 hours it will go to the system, process the data, and come. You need to be very careful that on designing kind of system because end of the day you don't want to be any slowness to your system, right? Because end of the day 2 hours it is loading the data, processing the data, then there will be some what you call the resource uses will be there on the system, right? And my RAM will be utilized, my CPU will be utilized. So based on that, your performance also can be. So this is a very tricky thing. We need to decide that what exactly can be done. But this is also one possibility is there in a real time that yes, can have each every 2 hours can have the data. That is
Okay.
possible. Okay. The
Okay.
second thing is instead of that, suppose I don't want to data analyst people, I don't want to connect to this for the area historical data. I want to connect. So the first problem is here we will not able to see the histories that will be getting captured or getting truncated daily or monthly, whatever maybe. So we have a limitation of data. Second thing is that which I'm talking about the normalization and the denormalization. I'll come to that. Here in the transaction area, right, all the tables are normalized. But we people work on normalization, denormalization, something like that. So here the transaction system where it works, they follow a certain principle of normalization, and that is called the ER diagram entity relationship. I'll come to the table, but I'm talking about the normalization. Like each table will be normal. But when you talk about your data analyst job, they don't work on the normalization, but they work on another modeling that is called the dimension model. That is called the dimension, and we'll come to that. But that's the way. And that was tested scenario that where your data analysts work, they work on the dimension. In fact, they work on the dimension modeling system. They are performing, but we'll come to that other thing. But this is an overall scenario that how thinking, and we can also correlate that I give an example to your banks. Okay? Any kind of things you are doing it online transaction with getting reflected immediately, and that they work on a transaction day. Whereas there is a delay on that one, then that is called the overlap. Makes sense? Questions up here? This makes sense, right?
Yeah, no questions.
All No questions, right? Anybody? Any questions you have? These are things you should know. Okay. Now, as I talk about the system which work on the transaction, so normalization. As I discuss about the normalization, this is the normalization. Now, it's like technique will be used to store the data in a particular. Okay, suppose I have a customer data, I should store in a table called. I have a product, should store in a table called product. It is not like customer and product will be mixed up and it will store in one. So there will be like a mix up bunch of problem. Why? Because somebody wants to search for the customer data, you need to search for customer and product because it is getting clubbed into one. If that is not the case, it should be getting. So you should be organize your storage area when you're talking about the database. That area, the storage, how the storage, so that it will be less redundant and good. So in that way, the way your techniques to design this all your normal. And if your system is a good design, right, compared like the operation of your content and processing very faster, then your insertion, your updation, and your deletion. Suppose you want to insert some record, you want to delete some records, you want to update some records on the database, that will perform fast because your system is robust. So to make it robust, then you find some. So there are different type of normalizations are available. First normal form, second normal form, third normal form, fourth normal form. There is a BCNF also there. Fifth, sixth, everything. But should know till third normal form is enough for you because end of the day, this is not our job. Frankly speaking, this is not our job. Design the system. This is more of a architect kind of. The database architect position will be there. They decide that how your system looks like. They will apply different principle and end of the day, when you are talking about a system, when you log into a system, right, you will get the data in a proper organization. Your job is to take this data, massage the data, transform the data to make it business usable for business so that they can get some insight. That is our risk. It's not like we need to design the system. I'm very clear on this. And you should be also understand in this as a this concept as a from an interview perspective only. Because end of the day, interviewer will ask you what is normalization. Know about the normalization, that's it. You need to answer. Never perform unless until you are into it. This makes sense?
Yes.
Okay, now here we're talking about the normalization. As I told you, that's a technique to organize the data such a manner that it will reduce the redundancy and dependency of your data. And this technique is to avoid the insertion, deletion, updation anomaly. Let's come to the anomaly here. Next chapter. Anomaly is nothing but how your data is looks like. So if you talked about this data, right? So here the problem is there are some duplicate data are available. 100, 1001, 102, 1003. All these things are duplicates, and that's the problem in this. First of all, the problem, and there is no constraint, there is no rule where you can define kind of. I can enter a null record also, right? Because there is no such rule you define. Suppose you want to update something for 1001. So let's say I told you that employee ID 1001 should be belong to sales. Then first 100 guys is already on the which 1001 what? Because there are some duplicate entries are there. The same lies for the insertion, deletion, updation. If there is a duplicate data, right, it is like your life will be very difficult. Identify that for which record I want to insert it or for which record I want to delete it, or for which record I want to. So that's called the anomaly. Anomaly is something like characteristics of your data, how your data looks. That's called the anomaly. So now this is called the anomaly. Next, go to the first normal. Suppose as per the rule suggest here, first normal form, and you by heart just remember this three lines, and you can explain with an example whenever you are going to an intro. So it's saying that this is from not my definition, this is coming from your database guys only, so who created this normalization. So the first rule says that an attribute of a table cannot hold multiple values. It should hold only atomic value, single value. Each record needs to. If these three principles works, then we can say that your table or where you are storing the data, it is on the first normal. So here, suppose take an example of this. We have an employee ID, employee name, your mobile number, and department. Here the first problem is customer have a different mobile, but we are keeping it in a single table only, or sorry, single column. It's saying the first street. Each record needs to be unique. Each record is unique here. If you see this E1001 John 343 sales. If I talked about the first row, there's a uniqueness is there. But the problem here in this table is the mobile number only. We are keeping more than one information. Okay. So that's what it's all about. So how to convert this table into a first normal form? So there will be a different data. So E1002 Smith and different phone number. Now you can say that there is a duplicate happen when I move from this table the first normalization. But if we talked about individual rows, right, each individual row is unique. So here's if we talked about E1002, Smith phone number, yes, no doubt, employee ID, their name, the department is same. But uniqueness is coming through the mobile number only. Okay. But still, this kind of data load or during this way, not good because still there is some redundant. Okay. Any questions up to here? The first normal form, and I can move it. I think somebody, any questions, guys? Anybody have anything? Please be active on the class. Is your second normalization form, second normal form. So there are two rules it is saying that. The first of all, it should be in the first normal form. Whatever the characteristics of your first normal form, it will goes on here as a hierarchy. Second is that all non-key attributes are fully functional dependent on the primary key. In simple words, it should not have a partial dependency. So something like that. So here we talked about a data here, something like that. So different employees have a different qualification and their age. Here, if I talked about the qualification is dependent upon the employee ID. Employee ID is depending on the age is depending on the employee ID. So everything is dependent. And we are not able to get the uniqueness here based on these two data, the employee ID and qualification, unless until this needs to be combined. Individual employee ID, there are some duplicacies there if I talked about. But if you compare with the qualification, like the employee ID, their qualification, and if I combine these two to make it as a composite, then there is some uniqueness will come into the question.
No.
Please hold on, okay? In the sense, any question is there, just do let. So here, next I'm going to the third normal form because as I discussed that, discuss till third normal form only. Beyond that, it is not that much of a requirement is there. So on the third normal form, the first rule says that it should be in the second normal form. That's the first rule. Third is that there is no transitive function. Here, if you see, there is a clear example. Employee ID, name, there is a zip or the postal code, and there are different cities. So here's if you see, the city is depending upon your postal code, 100%, and depending upon the employee ID. So indirect, there is a direct dependency of the city to your postal code. There is a indirect dependency of your employee. Here it is saying that whenever there is a partial dependency is there, city is partially depending on the employee ID, whereas city is directly depending upon your postal code. Because if I talked about a city name, sometimes with the name we will not able to identify unless until we have the postal code or the zip code, whatever may be, then only we can identify that this is the city. There is a direct dependency on that. Whereas if I talked about the city and employee, employee belongs to which city, that is not that important. When the employee ID, what is the name of the employee, that is the which city he belongs to, that is not that important from where he is coming up. So here the city and the employee name or the employee ID, there is some partial dependency. There is no direct dependency. If there are some partial dependency kind of data is there, third normal form says that please take out the data from that thing, put it into a separate table that are not direct dependent on. So to avoid that, like this. So here I can put the zip because I want to correlate the postal code and city needs to be moved it to another table, and finally you can connect back to the employee table so that the employee information will. This is the way third normal form works. Any questions up to here?
No.
And this is your fourth normal. So here it is saying that the relationship in fourth normal form means should be first normal form, second normal form, third normal form. Everything needs to be satisfied. Then there are some functional dependency all the time. Here if you talked about a day, I have some different students. They are enrolled to different courses and they have different hobbies. Right? So here if you talked about these two line under course and the hobby are two independent. Course and hobby are two independent. Exactly, right? Course and hobby, there is no dependent on because employee ID is enrolled for a course. He is having one hobby, but how course and hobby will those are both are independent. Hence, there is no relationship. Actually, there is no unless until it is tied up with the student or tied up with an employee. Any employee can have a course and enroll for a course. They do have the hobbies, but hobbies and course to compare in a single unit, there is no relation. So fourth normal form says that please remove the multi-value dependencies which are not related to each other. Right? Please move it. Don't keep it in a single table. All these things. These two are not related to each other. So if I has to avoid this, I can able to have a two tables. One is student ID course table where I will get only the course in which course the student enrolled, and I will have another table where I will keep my hobby in, where I will keep my student ID and hobby. And finally, when I am doing the data modeling, I will correlate these two tables, and finally I will get it all done. But it should not be there on a. That's what it is. Okay? This is called your first, second, third, and fourth. This PPT I will share it to you guys and have it make it handy. And any questions over here, ask me. And after going through the document also, you can ask me. I'm just stopping for a minute. If you have any questions, please go ahead. No?
No question.
Anybody with anything have?
No question. No.
So now let's talking about another very important topic on the SQL before entering to the database. That is called the acid property. Acid is not like chemical acid, but there is an acid. So if I talk about a transaction of your giving a flow chart, so your ATM transaction, if you are going to an ATM, your transaction begins. Then when you are entering your card in the ATM machine, then it is reading your details. Then you want to withdraw the amount, you are getting your amount. Then somewhat of the amount you enter there, it will be coming out from the machine. Right? So there could be two scenarios in this when you are doing the transaction. Either it's a success, sometimes it got failure, or whatever the reason, technical glitch or that system is not working. What could be the scenario? Either yes or no. Okay, if we are committing the transaction happening correctly. If it's a no, then it is saying that got right. This is the process. Everybody aware of this process? I think so. Everybody can correlate. Correct? Yes or no?
Yes, sir.
Okay.
Yeah.
So this is the process where what is called your acid or wall. Now what is the property when the transaction is happening? What are the different properties it is going? So acid stands for this. You need to remember. This is an interview question. What is acid? Acid A for atomicity, C for consistency, I for isolation, and D for durability. Okay, and I have given everything here. I don't want to read it. I will go to the example only. You can read that. What is atomicity? What is consistency? What is isolation? And what is durability? This is overall is called the acid. ACI, acid property. When any kind of database transaction is happening or database you are running in a system and you are doing something on there, fetching the data or you are inserting some data, you are deleting data. So it should follow one rule that is called the acid. A, atomicity, consistency, isolation, durability. These are the four rules which will be applicable to each and every statement when you are executing. Okay. So let's discuss about what is atomicity. You can correlate very easy. So here I have given an example here. Two customers are there. Atomicity is that ensure all operation in the work unit are complete successfully. Otherwise, the transaction is aborted at the point of failure. Abort or commit means that suppose I have the customer A, the customer A here, okay, and suppose he is having an account of balance of 800 and he wants to transfer the amount to the customer B of 200 to the balance. So when the successful transaction happened, so his amount should be 600, and whereas the customer B was having a 500 before, so his amount should be 700, and this should be automatic in the sense it should be you are doing it should be immediately it should be happen. 200 amount should be deducted from your account, 200 is to be reached to the customer as immediate you done it should be done it. That you are looking for your from your database system. Ensure that all your operations should be completed successfully. That is called your atomic. Makes sense? And suppose any kind of failure also happen, your amount should not be deducted. Okay, so 800, suppose you are transferred 200, it should not be 600, it should be 800. Sometimes what happen, any transaction got failed, some amount got deducted from our system, from our account, again it will come back. Right? Those kind of ensurity we are the customer is giving, that is called your atomicity. This makes sense, guys?
Yes.
Yes.
Now let's go to the acid properties here. Sorry, consistency. So here she says that ensure that the database properly changes states open a successful committed transaction. Done a committed transaction, successful transaction, but the that changes which I'm talking about, like suppose I have transferred 800, should be immediately it should show me give the balance 600. And the customer C should be add on that amount, and whenever I'm transferring to C, so whatever I'm doing the transaction, that transaction should be properly changes. So I'm deducting, it should be deducted. I'm adding up. So atomicity is something like it ensures that your all the transactions should be successful. Consistency is something like once the successful transaction happened, your changes should be properly. Should not be like I'm transferring 200 is getting deducted from my account 400. That is not possible. Atomicity, consistency. These two property understand?
Yeah.
Oh, now the isolation. Isolation is something like enable the transaction operate independently and transparent to each other. It means that customer A, you are transferring to the customer, okay, unless until the transaction is not happened and customer B, the amount is not getting deposited to there, right? You should not know what exactly the transaction happened. So customer B should not know how much I am doing. Unless until it is my friend, he should know that what I am transferring. But in a system, if somebody suppose I am transferring some amount to the customer B, and in between the transaction is not yet done, customer B should not see the data, like how much data I am getting it, or he should not in this account also the amount should not be showed up unless until it's a complete transaction happened. So both are needs to be on a isolation. Customer A and customer B should be isolated to each other, so that what they are doing the transaction unless until it is getting deducted from his account, unless until the amount got deposited to the customer B, both should be on a isolation process. Okay, so you want to understand this three property. Anybody have any questions?
Can you repeat this isolation process again, please?
Isolation. Okay, just be hold on. Suppose you are doing be on unmute only. Suppose you are doing a transactions to pay for your children's school fees. Okay,
Mm-hmm.
and you started your transaction. You are entering
Mm-hmm.
your details in transaction. So you know that how much you want to pay, but the school people can see that how much you are transacting on the time of transaction, or suppose they have 100 rupees and you are in between the transaction, can they get it another 100? Like their account should show 200? No, right? Because I have not yet. I'm starting up. So you and your should be on a isolation. By the time of they should not know what exactly happened unless until you. So both of you are on a isolation. That is called the isolation. Make sense?
Yeah, yeah, thank you.
And the last one is nothing that is that durability. Durability is very important of a system failure. Suppose any kind of system failure happen, the result or the effect of a committed transaction persists in case of system failure. Suppose any kind of in between your transaction, any kind of system failure happened, your amount got deducted, not yet received by them. So ensure that, and this system durability is that there will be no system failure in event and your transaction would be always in smooth. That ensure anybody on a bank. This applies not to a bank system, it applies to our also. When you are doing any kind of database things, right, should we make sure that all these properties should be taken, right? My transaction should not fail, my query should not fail, my data load should be proper, okay? My data load is faster unless until I not load the data, nobody should see other data. All this property always applies to databases. This property is called your asset. And the last, which is called the durability, should be ensure that whoever is on that place, but you have a data warehouse, you are loading the data, you should make sure that your database is always accessible. Should not be down, should not, suppose a customer is saying that I'm not able to access your database, I'm not able to see in data. That is not a good sign, a good system. Once in a while, it's fine. I'm not able to see, anything can happen. But if it is getting frequent things are going on, you're having a bad. So all this property you should always remember when you are working on a database. Make sense?
Yes.
All right. Any questions up to here?
No.
Very good. These are the two things which we require. Okay. Next, as a data analyst or the data engineering world, you should know one thing is called your dimensional model. We'll discuss this completely, but I'm just giving an overview right now today. We need to work on a dimension. Dimensional modeling is a modeling in the sense to organize your storage in the form of a table in a different way. Here, two things will come up. One is called your dimensions. Second one is called your facts. Just remember this. Okay. Dimension, and what is dimension, what is facts, which are non-numeric kind of data, that is called your dimension, and which are numerics or transactions which can be aggregate, these are called the facts. Okay, so let me give an example of this one. So if I talked about a customer, so customer table which holds customer information, okay, like let's take customer ID, name, address, then postal code, city, state, etc. Here, I don't have any transaction to be done on this date. I don't have anything. Like this is just a basic information, like the customer, the normal, non-numeric information. I don't have any numeric information. So this qualifies for a dimension. Okay. And when I'm talking about another data, let's take the product. Same, which will hold the information like your product ID, name, then which category it belongs to, what kind of product is this, what is the subcategory, okay, etc. These are the information which will hold by this. So this is called your product. So this is also qualifies for a dimension. Whereas I'm talking about my sales. Okay, here I have a the total sales. I have a target sales. Okay, then I have a monthly sales. Then let's take I have a quarterly sales. They are different. Now these are called all the numeric data, right? The numbers. So that this qualifies for a fact. So here if I talked about, if I ask you one question, that question is, let's take I have a customer called XYG. So what is the total? What is the total sales for customer XYG? This is the question. Then if I ask you this question by this three table, so this is my customer, this is my product, this is my sales, how you will get it? It's a basic question. Don't take that I need to answer it in a very professional way. No, I'm just asking very basic question. The customer is information is there, product information is there, and I have a sales information. So how I will get it? What is the total sales customer for the customer XYZ? If I ask you this question, can somebody answer this question?
You can just see the total sales basically from the sales.
Okay. So where will be the XYZ will be there? Because I want to search for the customer XYZ. Where this information will be available?
With the
In the
customer table.
correct, in the customer table, right? Customer table having a name, so that will be
Mhm,
XYZ. For
mhm,
that, there will be one customer ID as well, right? Suppose
mhm.
XYZ customer ID is 1001. Let's take. Okay. So I will take this 1001 and I will come to here to my sales table. Here there should be another customer ID should be 1001,
Yeah.
right? So that I will get 1001 sale. Here I will take from the customer table, I will take 1001 as a customer ID for the XYG. Then I will directly come to my sales table and search for 1001. Then I will take my, in this way it is possible. In this case, your dimensions and your facts should be related, should be in relationship. And when the dimensions and facts are on a relationship, here how the relationship is happening between your customer ID. Here I have a customer ID and I'm taking this customer ID to here called your dimensional model. I will discuss completely on this one, but I'm just giving an overview. Make sense? This is called your dimension. Questions?
No.
Okay. I'm done for today.